This is OpenNMS 101, Module 13, Part B, Provisioning Preliminaries. In Part A, 4 nodes were created and SNMP v3 was configured on each. The SNMP monitoring and collection extensions from previous modules were also configured. OpenNMS Discovery was appropriately configured and the nodes were provisioned. Tutorial monitoring and collecting was verified. The process works well, but there are a few drawbacks to provisioning through Discovery. Other provisioning mechanisms are available. Nodes can be provisioned through the GUI using requisitions. This will be covered in this video. Or nodes can be provisioned through the command line through a new suspect event or the provision.pl command. These will be covered later in this module. The material in the remainder of this module is extracted from the Horizon Operations Deep Dive documentation in Provisioning. During each of the remaining provisioning demonstrations, the following will remain constant: the node SNMP configuration, the OpenNMS tutorial requisition, the SNMP v3 access parameters, and the tutorial monitor service defined in polar-configuration.xml. Each of the provisioning methods will be demonstrated using these steps. Verify the nodes are in OpenNMS. Remove the nodes from OpenNMS and verify the nodes have been removed from the OpenNMS DB and file system. Add the nodes using the appropriate provisioning mechanism and verify the nodes are in the OpenNMS DB and file system. Backup the old node collection files, and finally, verify services and collection. To verify the nodes are in or out of the OpenNMS DB and file system, examine the contents of etc/imports/tutorial.xml. Examine a few of the node-related DB tables. Look at the node collection file system /opt/OpenNMS/share/rrd/snmp or /response. Begin in etc/imports. There are XML files in this directory for each requisition. Display the contents of tutorial.xml. Do not be concerned with the specifics of what is displayed, only that 4 nodes are listed in this file. Switch to the OpenNMS DB. The node table is referenced by a number of other tables through the node ID. The reference is defined with onDelete cascade, meaning that if the node is deleted, the referenced record in the table will be deleted. This tutorial will use the node, IP interface, and SNMP interface tables to verify that once a node is deleted, it has been removed from the OpenNMS DB. A set of queries has been created. The first lists all nodes in the tutorial requisition. The foreign source is the requisition name. The second query lists all the IP entries associated with the tutorial nodes, sorting on the node name. The third query lists all SNMP interfaces associated with the tutorial nodes, sorting on node name, and then SNMP interface description. Return to the SQL and execute the 3 queries. The first table is a list of tutorial requisition nodes. The second table is a list of IPs associated with the nodes, and the third table is a list of SNMP interfaces associated with each node. Each node had a loopback interface and the ENS160 interface. Return to the command line and list the files in var/OpenNMS/rrd/snmp. Remember that collected D metrics are stored by node ID. Node 8 is Denver, Node 9 is Sacramento, Node 10 is New York, and Node 11 is New Orleans. The Denver metric collection files are under SNMP/8. Delete the tutorial requisition nodes using the GUI requisition page. Click on Admin Configuration, and then click on Manage Provisioning Requisitions. On the tutorial requisition line, click on the far right button and select Remove All Nodes. Click OK, verifying the deletion. The tutorial.xml file no longer contains the node's information. The DB references to the tutorial requisition have been deleted in the node, IP interface, and SNMP interface tables. But the tutorial requisition's nodes metric collection files have been left alone. This can be used to create backups. Add the tutorial requisition nodes using the GUI requisition page. This is covered in the Horizon Operation Deep Dive documentation under Provisioning, Directed Discovery, Add Nodes, through the Requisition UI. From the Provisioning Requisitions page, synchronize the tutorial requisition. Edit the tutorial requisition by clicking on the pencil button. Click on Add Node. Under Node Label, add denver.localdomain. Click on the Interfaces tab. Click on Add Interfaces. Enter the IP address 192.168.159.106. This is the SNMP primary address. Click on Save. Click on Save. Click on Return. Verify the node line looks good. It should. Click on Add Node. Under the node label, add neworleans.localdomain. Click on the Interfaces tab. Click on Add Interfaces. Enter the IP address 192.168.159.109. This is the SNMP primary address. Click on Save. Click on Save. Click on Return. Verify the node line looks good. It should. Click on Add Node. Under Node Label, add New York.localdomain. Click on the Interfaces tab. Click on Add Interfaces. Enter the IP address 192.168.159.108. This is the SNMP primary address. Click on Save. Click on Save. Click on Return. Verify the node line looks good. It should. Click on Add Node. Under Node Label, add Sacramento.localdomain. Click on the Interfaces tab. Click on Add Interfaces. Enter the IP address 192.168.159.107. This is the SNMP primary address. Click on Save. Click on Save. Click on Return. Verify the node line looks good. It should. Click on Synchronize. Scan all nodes and click on Synchronize. Click on Return. Refresh the page. The 4 nodes are in the DB. Return to the console. There are new subdirectories in the OpenNMS metric collection subdirectories 12, 13, 14, and 15. Tutorial.xml has 4 nodes. The database node contains 4 tutorial requisition nodes. The node IDs are different than before, but match the new OpenNMS metric collection subdirectories. The IP interface and SNMP interface tables again reference tutorial requisition nodes. Return to the GUI and click on Info Nodes. Select denver.localdomain. The node needs time to establish monitoring and begin collection. Backup the old node collection files. The old node metric collection subdirectories can be deleted or backed up. Deleting is simple. Remove the node ID subdirectory. Sometimes it may be advisable to move the subdirectory to a different location. Suppose, for instance, that the deletion was performed in error and that the previous data is required. The moved directory could be used to retrieve lost data. At this time, there is no interest in moving or copying the IP response data. Still, if metric collection data is to be backed up, it might do well to create the backup response time directory. In this example, the directory would be /var/OpenNMS/RRD/backup/response. For the metric collection data, create the subdirectory /var/OpenNMS/RRD/backup/SNMP. Move each of the subdirectories associated with the deleted nodes to this subdirectory. SNMP/8 was Denver. SNMP/9 was Sacramento. SNMP/10 was New York. SNMP/11 was New Orleans. The live metric collection subdirectory is clean. Note the backup directory naming template, the node label .node ID. This will help if recovery is needed. The contents of the metric collection backup subdirectory is clear. Verify services and collections on the new nodes. It has been a few hours since the nodes were added. From the OpenNMS front page, select Info Nodes. Click on denver.localdomain. The services are up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 2 hours. The graphs look good. Select Info Nodes. Click on New Orleans.local domain. The services are up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 2 hours. The graphs look good. Select Info Nodes. Click on New York.local domain. The services are all up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 2 hours. The graphs look good. Select Info Nodes. Click on Sacramento.local domain. The services are all up. Select Resource Graphs and select all the tutorial indexes. Click on Graph Selection. Set the time period to last 2 hours. The graphs look good. Coming up, provisioning from the command line.